For the vast majority of its 4.5 billion-year history, Saturn had no rings. It drifted through the void as a featureless, beige sphere. The early solar system was highly chaotic until the movements of its largest planets brought order. The Grand Tack hypothesis describes Jupiter and Saturn migrating inward toward the Sun, then back out again. Their combined gravity acted as a massive anchor, pulling scattered debris into stable lanes. Saturn fulfilled this foundational role in the dark, locking into its permanent trajectory long before it ever acquired a ring system. The planet's legacy was defined by this gravitational utility. Long before it was an aesthetic icon, Saturn was a functional engine of orbital architecture. The rings arrived later, likely when an icy moon roughly the size of Titan drifted toward the planet. This schematic shows the Roche limit, the point where a planet's tidal forces become stronger than the gravity holding an object together. When the moon crosses this threshold, the pull on its near side becomes much more intense than the pull on its far side. The moon's structural cohesion fails. Under the strain of those unequal forces, the entire world shears apart, shattering into trillions of icy fragments. The destruction of this satellite provided the raw material needed to construct the rings. The current system is the result of that world's physical collapse. Over millions of years, the chaotic cloud of debris flattened into a thin disk. That disk is almost entirely water ice, 99.9% pure. Pure water ice has a specific refractive index, a mathematical measure of how much light bends and scatters as it passes through a material. The brilliant, crystalline luminescence we see is the result of that scattering. The rings are an optical effect generated by sunlight hitting billions of tons of shattered ice. Because we are observing Saturn today, we see this highly organized structure. But we are witnessing a temporary state of organization. Small satellites called shepherd moons are embedded within the ice. They use localized gravity to herd particles, clear gaps, and maintain the ring's sharp boundaries. Without these shepherd moons and their gravitational resonances, the ice would lose its structure. The sharp edges would blur, and the particles would drift apart. The rings are not a static monument. They are an active, churning machine, constantly working to maintain their own shape. During its final orbits in 2017, the Cassini spacecraft gathered data proving that this structure is decaying. The telemetry confirms the rings are actively disappearing. This is ring rain. Ultraviolet light charges the icy grains, allowing Saturn's magnetic field lines to catch and pull them into the atmosphere. Every single second, 44,000 kilograms of ring material is siphoned out of orbit and lost to the planet below. We are watching a slow-motion erasure. The rings are bleeding out, and their total disappearance is inevitable. Within 100 million years, the rings will fade. Saturn will return to the plain, beige state it maintained for its first 4 billion years. As the rings vanish, the spotlight moves to the moon Enceladus. It currently conceals a global saltwater ocean beneath a frozen crust, kept liquid by the friction of Saturn's gravitational pull. In the distant future, the Sun will expand into a red giant. As it swells, the solar system's habitable zone will migrate outward, eventually reaching Saturn's orbit. The heat from the dying Sun will reach Enceladus, melting the ice shell and exposing the vast, sunlit ocean beneath. This melted world will serve as the solar system's final window for life. It is a last, brief oasis before the Sun consumes the inner planets and finally fades into the dark.